the order of the reaction, right? So rate kinetics as well as how to find out the rate of an equation and the rate kinetics of an equation, so that we determined yesterday. So in today's class, let us see what is the order of the reaction. Okay, just a minute. So order of the reaction is nothing but the summation of summation of the power which is present on the molar concentration of the reactants or products. But here most of the time we are taking the reactants. Okay, so that's why we are going to concentrate on the reactants here. Say for example, here we have taken A and B as a reactant. Here is an equation 2A plus B gives rise to C and plus 4D. We are not concentrating on C and D because any of the side you can take, either reactants or products. Here we are concentrating on the reactants. Okay, and the rate expression is rate is equal to K is into A into B. Here square bracket indicates molar concentration. In the previous class only I told you about this. ಇದನ್ನ ನಾವು molar concentration ಅಂತ ಹೇಳ್ತೀವಿ. ಅದಕ್ಕೆ ನಾವು square bracket ಹಾಕ್ತೀವಿ. So what is its order? Okay, order of the reaction ನಾನು ಹೇಳಿದಂಗೆ summation of the power of the respective stoichiometric coefficients. And one thing you have to remember here, see, as 2 is present here, in the power of A 2 should come and 1 ಇಲ್ಲಿ ಏನು ಇಲ್ಲ ಅಂದ್ರೆ 1 ಅಂತ ತಗೋತೀವಿ. So power ಅಲ್ಲಿ 1 ಅಂತ ಬರಬೇಕಿತ್ತು according to the equation, right? But all the time it should not be same with the stoichiometric coefficients that what we have used to balance the equation. Sometimes it is experimentally determined and how many moles have been utilized for the reaction actually. ಅಂದ್ರೆ ಅಲ್ಲಿ ತಗೊಂಡಿರಬಹುದು ನಾವು, ಬಟ್ ಆಕ್ಚುಲಿ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಅದರಲ್ಲಿ ಎಷ್ಟು ಮೋಲ್ಸ್ ಕನ್ಸ್ಯೂಮ್ ಆಗುತ್ತೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಹಿಯರ್ ಡೋಂಟ್ ವರಿ, ವೈಲ್ ಎಕ್ಸ್ಪ್ರೆಸಿಂಗ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್ ಡೈರೆಕ್ಟ್ಲಿ to the power 2 and 1. But here themselves they have given rate is equal to K into A to the power of 1 and B to the power of 1 by 2. So order is equal to summation of the powers. Illi enu illa antandre 1 irutte, hauda? So if nothing is there, then it is understood that 1 will be present. Therefore 1 plus 1 by 2. Okay, so this is the order of the reaction. Order of the reaction can be written as 1 and a half. Or else you can also write 3 by 2. 3 by 2 ಅಂತ ಕೂಡ ನಾವು ಬರಿಬಹುದು. 2 LCM ಆಗುತ್ತೆ. 2 3 2 1s are 2, 2 plus 1 3. Or it can be written as 3 by 2. So remember, order can be a decimal, a fraction, a whole number, or it can be maximum up to 4 also. ಏನಾದ್ರೂ ಇರಬಹುದು. It is not like that always an order should be in a whole number. Okay, fraction ಅಲ್ಲಿ ಕೂಡ ಇರಬಹುದು. That means those many molecules are utilized in the reaction. Now I'll give you some example. For example, see example number 2. Okay, this is, take it as example 1. Now the rate of a reaction is equal to K into, say for example, X and Y, and in the power it is 1 and 2. What is the order of this reaction? Can anybody tell me what is the order of this reaction? Yes, 3 is the order of the reaction. So that means you understood how to find out the order of the reaction, right? And one more example I'm going to give. Third one, if rate of a reaction is K into, say for example, A into B and 1 plus 1 by 2 and 1. 1 by 2. Okay, what is the order of this reaction? Quickly. What is the order of this reaction? X1 is the right answer. Half plus half, that is 1, right? Yes, correct. So 1 is the right answer. So shall we go to the next question? That is, till now we discussed about R, and one more last example I'm going to give you, in which you have to find out the rate expression for the equation, as well as you have to find out the order. Example, see, here is a equation P plus Q, where whose coefficients are 2 and 3, gives rise to uh, R and S, 3 and 1. Example, this is an example. Find out the rate expression for this equation as well as order. Or else you can directly just tell me the order. If you feel difficulty to type the rate equation in the chat box, just you tell me about the order. What is the order of this equation? Third example. See, the rate expression for this equation can be given as, that is, K is a rate constant, proportionality constant you can say, and here we have two reactants P and Q, and as the stoichiometric coefficient for P is 2, so 2 will come as a power, and here it's 3. What is the order? It is the summation of the powers, 2 plus 3. Therefore, the answer is 5. Okay, now you understood, I hope. So this is about order, how to find out the order of the reaction. So let us see the next topic. Right. So this is very important, students. Already I had done this, but in order to find out some answers for problems, I need to repeat this. Who have not attended that class, or else who have not got this recorded class, you can now learn an integrated rate equation for a zero order reaction. Here, about order we learned, and also we learned how to find out the order of a reaction. So many types of order of a reaction are there, like zero order, first order, and second order. For derivation, we have only two, that is zero order and first order. Zero order reaction means a rate will be depending on the zeroth power of the concentration of the reactant. Okay, zeroth power of the concentration of the reactant ಮೇಲೆ depend ಆಗಿರುತ್ತೆ, because it is a zero order. If it is first order, then the rate will be depending upon the first order of the concentration of the reactant. Okay, I'll tell you about that while dealing with the first order. Now you remember, power ಅಲ್ಲಿ zero ಇದ್ರೆ ಅದನ್ನು ನಾವು zero order reaction ಅಂತ ಹೇಳ್ತೀವಿ. Okay, means rate ಯಾವುದ್ರ ಮೇಲೆ ಅಥವಾ velocity depends on the zeroth power of the concentration of the reactant. Remember this. Okay, now let us derive an equation, an integrated rate equation for zero order reaction. So let us consider a general equation: reactant gives rise to product. Okay, this is a general equation. Now how to express rate equation for this? Since it is zero order reaction, rate can be written as rate is directly proportional to the zeroth power of the molar concentration of the reactant. Okay, so if I remove this proportionality symbol, then rate kinetic constant or kinetic constant ಅಂತ ಕೂಡ ಹೇಳ್ತೀವಿ, or rate constant K into R to the power of 0. Okay, now rate can also be expressed as, ಸೊ ನೆನ್ನೆ ಕ್ಲಾಸಲ್ಲಿ ಹೇಳಿದ್ದೆ ನಿಮಗೆ ಹೇಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಬೋದು ಇದನ್ನ. ಆವರೇಜ್ ರೇಟ್ ಅಲ್ಲಿ ಅಥವಾ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ರೇಟ್ ಅಲ್ಲಿ ನಾವು ಇದನ್ನ ಬರೆಯೋದಾದ್ರೆ, ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಎಕ್ಸ್ಪ್ರೆಸ್ಡ್ ಆಸ್ ನೆಗೆಟಿವ್ TR by dt. This is instantaneous rate, because compared to average rate, instantaneous rate equation or rate determination is very much important and easy for us, because every instant of time, how much reactant has been consumed and at what rate it is happening can be detected easily, compared to average rate, which will be mentioned in delta. Okay, average rate andre adu tumba gap agutte, time interval will be more, whereas instantaneous rate is a short instant of time. Okay, so dr by dt. Now let us compare this equation and this equation. LHS are same, rate and rate. So can we compare the RHS? Right, because as LHSs are same, the RHS will be equal to same. Okay, so therefore this equation can be written as minus dr by dt is equal to k into r to the power of 0. Any number to the power of 0 is nothing but 1, right? So therefore minus dr by dt is equal to k into 1. 1 is because r to the power of 0 is nothing but 1. Then k into 1 is k. So I'll shift this negative sign towards right side. Then what I'll get, that is k minus k into dt, because this dt also I'm sending towards RHS. So what remains in the right side? Just dr. Okay, so now this type of equation we got. I'm going to repeat this. See, any number to the power of 0 is nothing but 1. So 1 into k is k. This dt I'm sending towards RHS, then k into dt is k dt, and negative sign also goes towards right side. Therefore, minus k into dt is k dt. So again I'm going to rearrange this. dr is equal to minus k dt. Finally, we got this. Now integrate this equation on both sides. Integrate the equation on both sides. Right. So now, see, integration is nothing but variability, that is between initial and final values. So here, in order to find out the rate of the reaction, initial and final levels are very much important here. It may be related to reactant or product or related to time. So just variation anta ಹೇಳ್ತೀವಿ ನಾವು. And one thing you have to remember, integration is the inverse of differentiation. So whatever here we have taken d, that is difference between anta. Instantaneous rate anta ಏನು ತಗೋತಿದೀವಿ, initial ಹಾಗೂ final ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. How much it was in the initial and how much it is at the final level. So difference anta ಹೇಳ್ತೀವಿ. ಸೊ ಈ ಇಂಟಿಗ್ರೇಷನ್ ಈ ಡಿಫರೆನ್ಸ್ಗೆ ಆಪೋಸಿಟ್ ಆಗಿರುತ್ತೆ, ಇನ್ವರ್ಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅ ಸಿಂಬಲ್ ಫಾರ್ ಇಂಟಿಗ್ರೇಷನ್. Integration of dr is equal to minus integration of k into dt. So now, as I told you, differentiation and integration are the inverse or opposite. We can cancel this. Generally, mathematical expression alli helbekandre integration of dx is equal to x. Okay, integration of dx is equal to, the value will be x. Similarly, instead of x, what we have here, r. Therefore, integration differentiation hogi namge ಏನು ಉಳಿಯುತ್ತೆ, r is equal to negative sign remains as it is. Here also we have d, integration and this differentiation goes out, kt remains. And one thing you remember, k is nothing but the rate constant. K andreno rate constant. So whenever you integrate a constant, integration constant na kuda ನಾವು ತಗೋಬೇಕು, that can be represented with the sign I. Or sometimes you can also take it as C. Excuse me. So kt plus I anta ತಗೋತೀವಿ. So kt as it is, ಇಲ್ಲಿ d ಮತ್ತೆ integration cancel ಆಗಿದೆ. So why we have taken I here is because whenever you are going to integrate any constant, integration constant has to be taken, right? So consider this as equation 1. Now when time is equal to 0 seconds, ಯಾವಾಗ time 0 seconds ಆಗಿರುತ್ತೆ, consumption of the reactant will be equal to 0. ಅಂದ್ರೆ ಟೈಮ್ ಇನ್ನು ಸ್ಟಾರ್ಟ್ ಆಗಿಲ್ಲ, ಬಿಗಿನ್ ಆಗಿಲ್ಲ ಅಂದಾಗ ಕನ್ಸಂಪ್ಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ ವಿಲ್ ಬಿ 0%. ಏನು ಕನ್ಸ್ಯೂಮ್ ಆಗಿರೋದಿಲ್ಲ. ಇಟ್ ವಾಸ್ ಇನಿಷಿಯಲಿ ಹೌ ಮಚ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್, ದಟ್ ಮಚ್ ರಿಯಾಕ್ಟೆಂಟ್ ವಿಲ್ ರಿಮೈನ್ ಅಟ್ ದ ಎಂಡ್ ಇಟ್ ಸೆಲ್ಫ್ when the time is equal to 0 seconds. Until we increase the time, the reactant concentration remains same. So R naught is nothing but initial concentration. So final kuda initial ge equal ಆಗಿರುತ್ತೆ, initial concentration. Okay, this is final. So final will be equal to initial concentration. Now, so let us substitute these values in equation 1. Excuse me. Equation 1 ಅಲ್ಲಿ ನಾವು ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. Then what will get? Okay. Just a minute. Okay. So let us substitute those values in the equation 1. So I'll write it here. Okay. So equation 1 is R. So final value will be equal to initial value. So in the place of R, I am writing R naught is equal to minus K. T value will be 0. You can see here T value in either 0 seconds and R value R naught either. So that I am substituting here plus I as it is. Okay. So now what I am going to get? R naught as it is equal to, now K into 0 is nothing but 0 plus I. So R naught value will be equal to I. Consider this as equation 2. Now substitute equation 2 in equation 1. Okay, what we'll get? This is equation 1. R value as it is equal to minus KT plus, what do you mean by I here in the equation 2? R naught. I is nothing but R naught. Therefore, minus KT is equal to, minus KT will be sent here. When it comes to the RHS, it becomes plus. So R I am going to send to the RHS. So R naught minus R. What is the value of K? R naught minus R whole divided by T. Okay, so this is an integrated equation for a zero order reaction. See, we started from here. Rate is equal to K into R to the power of 0 because it is a zero order reaction. So this is a rate expression. The K is called rate constant, which is also a proportionality constant. Rate can also be expressed like this. This is instantaneous rate equation minus dr by dt. So when we compare these two equations, we'll get the equation like this. And any number to the power of 0 is nothing but 1. Minus k into dt is equal to dr after rearranging this and integrating this equation on both the sides. By that, differentiation and integration is inverse of each other. By that, these two get cancelled and r remains. And whenever you are going to integrate a constant, the integration constant has to be taken, that is I. So that's why I is a new letter which is coming from this line. Okay. And when time is equal to 0 seconds, the final concentration will be equal to the initial concentration. Yakendre time increase agde reactant consumption agodilla. Okay, yesterday's class alla nimge helidde. So consider this as equation. Okay, so this too should be substituted in equation 1. So now we are going to get like this. T alli 0 na substitute ಮಾಡಿದೀವಿ, R ಜಾಗದಲ್ಲಿ R naught. So R naught value will be equal to I. When it is substituted in equation 1, ultimately we'll get this equation. Okay, so this is how by integrating the rate equation we can find the final equation. So any doubts in this derivation? Okay, now we'll move on to the half-life period for a zero order reaction. Idra half-life period anna hege kandidiyodu anta nodona. So before that, I'm going to tell you about the half-life period. What do you mean by half-life period? So half-life period is nothing but the time exactly required to reduce the reactant to its half. Okay, initially ಅದು 100% ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Excuse me. Okay, initially if a reactant is 100% concentration, exactly ಇದು 50% reduce ಆಗೋಕೆ ಎಷ್ಟು time requirement ಇದೆ. So this is called as the half life period of the zero order reaction, or even it is there for first order reaction. Okay, 100% ಇರೋ reactant ನ ಅದರ exactly half 50% ಗೆ reduce ಮಾಡಕ್ಕೆ ಬೇಕಾಗುವಂತ time ಅನ್ನ half life period ಅಂತ ಹೇಳ್ತೀವಿ. So let us find out this half life period for a zero order reaction. Half life period can be represented as T 50% with a symbol, or it can also be written as T half. T 50% ಅಥವಾ T half ಅಂತ ಕರಿತೀವಿ. Okay, zero order reaction ಏನು? For a zero order reaction integrated rate equation just now we found, that is K is equal to R naught minus R whole divided by T, right? So this is an integrated rate equation for a zero order reaction. Now we have to find the half life period of it. Half andre ಏನು? ಇದು T 100% andre T half 50% ಇರಬೇಕು. So K is equal to R naught is the initial concentration. Initially 100 ಇದೆ. Finally how much it has to be? It should be 50%. That means initially na ಅರ್ಧ. So ಹಾಗಾದ್ರೆ initially na ಅರ್ಧನ ನಾವು R value can be written as R naught divided by 2 ಅಂತ ಬರಿಬಹುದು. Okay, this is half life. So ಅದನ್ನ ಇಲ್ಲಿ ನಾನು substitute ಮಾಡಿದ್ದೀನಿ, whole divided by T half, because we are finding out the half life period of it. So T half I'll take in the LHS and K should be sent to the RHS. 2 as a LCM will take, ಇಲ್ಲಿ 2 ಇಲ್ಲ, therefore it becomes 2 into R naught minus R naught as it is, whole divided by K. Okay, now T half is equal to 2R minus R naught, 2R naught minus R naught divided by 2K. Okay, as both are in the denominators 2K. Now just observe the numerator. 2R minus R is nothing but R naught, right? R naught divided by 2K. So this is the integrated rate equation for half life period for a zero order reaction. Ee question anna nimge write the relation between half life and zero order reaction antanu kelbodu, athwa find out the half life period for a zero order reaction antanadru kelbodu. Just you have to substitute R naught by 2 in the place of R and T half in the place of T. Okay, then ultimately you'll get an equation like this. Okay, right. Any doubts in this derivation? So now after finishing the derivation of half-life period, let us go to the next reaction, that is derivation of integrated rate equation for first order reaction. Okay, remember it is based on the order, rate depends on the order, rate is equal to, if it is first order, K rate constant, R to the power of 1. Okay, R to the power of 1. So that means first order reaction always depends on first power of the reactant's concentration. If it is 0, then rate is equal to K into R to the power of 0. This is for zero order. Okay, similarly second order rate is equal to K into R to the power of 2 anta agutte. So this is for second order reaction, or else rate is equal to K into, if we consider two reactants A and B, this is also the second order reaction, because here if nothing is there, one will be there. If we add those powers, then we will get 1 plus 1, that is 2. This is second order. Second order reaction can be expressed like this or like this. Okay, don't worry about this. This is not there for your syllabus to derive an equation. derivation ಗೆ ನಿಮಗೆ ಫಸ್ಟ್ ಆರ್ಡರ್ ಅಂಡ್ ಝೀರೋ ಆರ್ಡರ್ ಮಾತ್ರ ಇರುತ್ತೆ. ಓಕೆ, ರಿಮೆಂಬರ್ ದೀಸ್ ಈಕ್ವೇಶನ್ಸ್. ಅಬೌಟ್ ದಿಸ್ ಆಲ್ರೆಡಿ ವಿ ಲರ್ನ್, and about this I'm going to derive the equation, but now we have don't have much time to derive this equation. So in tomorrow's class, first we'll solve the few problems based on zero order reaction. Later we'll go for the derivation. Okay, so if you have any doubts in the finding out the order of the reaction, as well as this derivation, if you have any doubts, you can ask me now. Okay.